Welcome back, Cubs. In this video, we're going to provide some assistance for the mole ratio and mole worksheet. It can be found under Topics, Chapter 9. This is due Tuesday by 3 p.m. Upload it as a PDF. Please start to use that Adobe Scan mobile app or another PDF scanning app so that we can read your work. Make sure that you are showing all of your work. Don't just give me the answer. I need to show, you need to show me the work too. Also, please include your name on the work as well. You don't have to print out this worksheet. You can just write down the questions and answers and show your work. So in this video, we're going to go over the mole ratios right here for this second problem, and then we'll also take a look at how many moles of aluminum oxide this problem right here to walk you through those. So here we go. For mole ratios, remember we're going to use the coefficients. So coefficient. We're doing a comparison here. So we want to compare potassium chlorate to potassium chloride and potassium chlorate to oxygen. So we have 2 moles of KClO3 over 2 moles of KCl. Then we have 2 moles KClO3 and 3 moles of oxygen. Now we're also going to compare, use a different color. We're also going to compare potassium chloride to potassium chlorate and potassium chloride with oxygen. So we're just using the coefficients here. So 2 moles of KCl over 2 moles of KClO3, and then 2 moles of KCl over 3 moles of oxygen. So all we're doing is setting up mole ratios that could be used for stoichiometric calculations later. Lastly, we have oxygen, comparing that to KCl, and oxygen comparing that to KClO3. So that's going to be 3 moles of O2 over 2 moles KCl, 3 moles of O2 over 2 moles KClO3. So these would be the 6 mole ratios for a 3-compound balanced chemical equation. Okay, moving on to the mole-mole stoichiometry. So recall that mole-mole stoichiometry, our given is going to be in moles. To find the given, look for the number. Oh, there's a number. So 0.325 moles of oxygen. And our unknown, what we're looking for, this is indicated by determine the, find the, how much, how many moles. So we're looking for moles of aluminum oxide, Al2O3. Okay, so we have mole to mole, so it's a mole to mole stoich. So we write our given, 0.325 moles of oxygen. This first unit, whatever it is, it's always going to drop down right here. So moles of O2. And now that we're in moles, we can go to mole of Al2O3. Notice, when we have mole over mole, that's when we can change substances. If this was gram in mole, we couldn't change substance. Mole over mole, that's when we can change substance. Also, where do we get the values for mole over mole? Mole over mole, refer to the balanced chemical equation and use the appropriate coefficient. So that means aluminum oxide is a 2, and oxygen gas, its coefficient is a 3. So make sure the units cancel out. They do. we're left with moles of Al2O3. So let's type this into the calculator. We've got, here you can see this, 0.325 times 2 divided by 3. So 0.217, 0.217 moles of aluminum oxide. Box or circle your answer. So just a reminder, when it's mole stoic, that means we're going to have mole of A. This drops down. Mole of B. This will give us mole of B. Those cancel out. The value here comes from the question when we have mole over mole. Mole over mole, use coefficients from the balanced chemical equation. Okay, let us know if you have any questions. Feel free to use the discussion board, Remind, or email. Have a great day, Cubs.